And this is finding limits. And we're looking at two ways. First of all, we're going to do numerically. And second, we're going to do graphically. Now, in that video, did he talk a little bit about a limit? What? Okay, so what I'm going to ask is that you watch the videos for 1.2 for tonight too. He does talk about what a limit is, and a limit is actually something we need to learn before we can discuss the two main questions of calculus. So they're already on Canvas. Yep. So, and it might just be one video. I'll have to look. Trevor? All right. So finding limits is something that we have to learn how to do before we can learn to find the slope of a curve or learn to find area under a curve. And so the idea of a limit is, I like to think of a limit as something that a graph approaches. It may or may not get there. Okay? And the video should kind of give a good explanation of that. So a limit is something that as you're approaching. So let me just show you the first like a limit problem that you'll be working with. So let's just take a look at, let's say I wanted to find the limit as x goes to -3 of the square root of 1 minus x minus 2 all over x plus 3. It's right up here. It is in the book too, but all right, so this is a numerical, finding a limit numerically, and this is going to be like problems 1 through 3 and 6 through 8, or 1 through 3 and 6. So if I want to find a limit numerically, the first thing I have to learn to do is read this problem. This is read as the limit as x goes to -3. The limit as x goes to -3 of that function. And a limit, when I say limit, can any of you think of limits in real life? Speed limits. All right, speed limits. Can you actually go the speed limit? Can you go higher than it or lower than it? All right, so so a limit is there. It's kind of a guideline, right? How do you usually think of a limit other than a speed limit? The sky, the floor, okay. Gravity, what? Temperature. Okay, what do you mean? Okay. So there's a limit is something like you maybe could get to, or you never could get to, right? But okay, so absolute zero is an excellent way to kind of think about limits. Okay, can you ever get to absolute zero? So why do we talk about it? Because what? Because it exists. But does it mean we have to get there? No. Okay, so a limit is something we may or may not be able to achieve. It just depends on the scenario. Okay, so what we're asking for is, what is the, basically we're just saying, what is this function's y value? Okay, what is this function's y value approaching as I put x values that get closer and closer to -3? So we might want to write that out in words. What is this function's y value approaching, getting close to, as its x value as we put x values in that get closer and closer to -3? That is the question you want to answer. What is this function's y value approaching as we put x values in that get closer and closer to -3? And that's the question every time you're asked a limit problem. Whether they give you a graph or a function, it's the same statement. You're just changing maybe closer and closer. That number can change and the function can change. But when we put numbers into a function, it's a y value that we're getting out. So then what you'll notice in your book is that you've got this table below it. And the table looks like this: x and f of x. And then it's got numbers in it for you already for today, because we're just starting out with limits. And the numbers are -3.1, and then -3.01, and then -3.001, and then -3, -2.999, -2.99, and -2.9. So they give you this table. So does anyone know what we maybe are supposed to do with this table? Plug in this number for what? X into here and work it out to get the y. Isn't f of x another way to say y? Okay. So now tell me, are these numbers getting closer to -3? -3.1, -3.01, -3.001, are those all approaching 3 or -3? Yes? Some of you think that approaching -3 would be numbers like -6, -5, and -4. Okay, the key is when we're dealing with limits, we have to look as close to -3 as we possibly can. Okay, are these numbers -2.9, -2.99, and -2.999, are those also all getting closer to -3? Yes. Why do we need both of those? How many ways can you approach -3 on the x-axis? Okay, here's the graph. Here's the x-axis. Here's 1, here's 0, here's -1, -2, -3, and -4. How many ways can I come at -3 if I'm on the x-axis? 2 ways. I can come from below, right? Or I can come from above, which is plus, from below is minus. Does that make sense? You can't see that. Okay, so I can come from below -3 and from above it. And every time you have any number, as x approaches 0, you can approach 0 from above it and from below it. So you can always approach a number in 2 places. So what you notice in this, if I'm trying to numerically find a limit, I should have that number that it's approaching in the middle. See how that's in the middle? And I put numbers starting, aren't these two the farthest away? And then I just get closer and closer. So we want to look at the key to figuring out our answer, because we aren't going to know that. The key to figuring out our answer is looking at the progression of what happened, what is happening to these numbers progressively. Okay, so now here's the hard, tedious part that you have to do. I'm not going to do this. Okay? You are going to plug in -3.1 in for that x and in for that x and follow the correct order of operations and work it out. But you're not going to do every one of them. Each row in here is going to do one of those. All right? Okay, so we're just going to start over here, this side of the room, 3.1, 3.01, 3.001, -2.999, -2.99, and -2.9. But stop for a second. I'm going to put -3. I want you to pay attention to this, please. I'm going to put -3 in. Watch what happens. When I put -3 in, when I put -3 in, I get the square root of 1 minus a -3 minus 2 all over -3 plus 3. What do I get on the bottom?
0.
Does it matter what I get on the top then?
No.
Actually, I get 0 on the top too. This is something I can't figure out. This is undefined. So I don't know what this limit is. In fact, this function, as far as I can see, is actually undefined right there. That function is undefined right there at -3. But here's the big step you have to make with limits. I can still answer this question. Because remember with that 0 degrees, absolute 0, can we ever get there? But isn't it still a goal? Okay, so these numbers are going to tell us what this would be approaching, what possible value this would be if I could actually work it out. All right, so plug it in, and you've got a whole row of people. Some of you have like 6 people doing the same number. Double check with each other, and I need someone from your row to come up and write the numbers in. I'm not going to write them in. You got to write them in. I need your focus back up here now. Okay, so what are these numbers getting closer to? -0.2485, -0.2498, -0.24998. What do they all round to? -0.25. What do all of these getting closer to? -0.25. These are getting closer by going down. These are getting closer by going up, getting closer to -0.25. So what do you suppose the limit as x goes to -3 of this horrible function is? -0.25. But it's by looking at the progression of these numbers that you decide that. All right, so yes?
The ones on the right are actually going down, the ones on the left.
Yeah, these are going, if I'm reading it this way, it's going down to that. These are going up to that. From left to right, they're all going up. With what number being right here? -0.25. Would you agree?
Yeah.
Okay.
My bad, I thought.
All right. No, your answer to this question is -0.25. But yes, this is a y value. Okay? A y value. But it's the answer to this limit question. It's just -0.25. That's all you put. The limit as x goes to -3, the limit as x goes to -3 of that is -0.25. That's all it is. It is a y value, but that should be understood. All right, so the next type of question that you need to answer is the question on graphical limits, finding a limit graphically. All right, so I'm going to draw a graph up here. Now, in your book, you'll have functions that you can deal with, but you don't need to deal with the functions. All you have to have is a graph.